Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have, this is nice cubic equation. This is a cubed plus a square equals to 36, and we solve this problem for all the values of a. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. So here we move toward the solution of this problem. So we have, this is a cubed plus a square, and first we rewrite this equation as a cubed plus a square equals to, we break this 36 as 27 plus 9. We know that 27 plus 9 becomes here 36. And now we rewrite this equation as, this is a cubed plus a square equals to, this is 27, we write it as 3 cubed, plus this is 9, we write it as 3 square. So we move all the terms from right hand side to the left hand side, and it will becomes a cubed plus a square. This is minus 3 cubed and minus 3 square, and this whole equation is equals to 0. And now in the next step we need to make the pair of cubic term with cubic term, and we get a cubed minus 3 cubed and plus this will becomes here a square minus 3 square, and this whole equation is equals to 0. And now further in the next step we need two nice formulas. So the first formula is, if you have x cubed minus y cubed is equals to x minus y times of x square plus xy plus y square. And here the second formula is square. We know that x square minus y square equals to x minus y times of x plus y. So we need these two nice formulas on here, and first we apply the cubic formula on the first factor. And when we apply this formula on here, it will be written as a minus 3 times of a square plus a into 3 plus 3 square, and plus in the second factor we apply here the second formula. So it will be written as a minus 3 times of a plus 3, and this whole equation is equals to 0. And now in the next step you see here both of these two terms involve a minus 3, so that we will be take common a minus 3 from here, and when we take common a minus 3 we get the remaining values are, from here we get a square plus 3a plus this 3 square becomes 9, and from here when we take common a minus 3 we get the remaining values are a plus 3, and this whole equation is equals to 0. And further in the next step we need little bit more simplifications, and it will be written as a minus 3 times of, this is a square plus 3a plus a becomes here 4a, and 9 plus 3 becomes 12, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a minus 3 equals to 0, and the second case is we write a square plus 4a plus 12 is equals to 0. From here we easily get the first root of the given equation, that is a equals to plus 3. And from here you see that this is the quadratic equation, and we know that there are three methods to solve the quadratic equation. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we apply the quadratic formula to solve this quadratic equation. For this we first write the coefficients of this equation, and its coefficients are capital A is equals to 1, capital B equals to 4, and capital C equals to 12. And we state the quadratic formula as A is equals to minus B plus minus square root of B square minus 4 times of AC divided by 2 times of A. So here we substitute all the values of A, B and C in this formula, and it will be written as A is equals to, this is minus B, the value of B is 4 becomes minus 4 plus minus square root of B square. So B is 4 square minus 4 times of A is 1 and C is 12, and it is divided by 2 times of A, and here our A is equals to 1. And now in the next step we have, this is minus 4 plus minus square root of 4 square becomes 16 minus 4 times 12 becomes 48, and it is divided by 2 times of 1 is equals to 2. And now here in the next step we have our a is equals to, this is minus 4 plus minus 16 minus 48 becomes minus 32, and it is divided by 2. And now in the next step we have minus 4 plus minus. Here we rewrite this equation as, this is square root of 30 minus 32, and we know that as 32 is equals to 16 times of 2, and this is square root of minus 1. We write it here, and it is divided by 2. Further in the next step we have, you know about that, minus 4 plus minus square root of 16 becomes here 4 times of square root of 2, and we know that the square root of minus 1 is equals to iota. Further we break this fraction and we write these two separately on both of these two values. Okay, so further in the next step we need to cancel these terms, and we have, this is 2 times 2 becomes 4, and we get a is equals to minus 2 plus minus, this is also 2 times 2 becomes 4, and we get 2 times of square root of 2 into iota. So these are the other two complex roots of the given equation, and we get there are one real root of the given equation, and it is a equals to 3. So these are the three roots of the given equation, in which two roots are complex and one root are real root. This is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.